Hello and welcome to lesson 5.4 on the rational root theorem. So we're going to talk about what the theorem is. Here I'm going to give a sort of formal definition of it, but you'll probably learn it better when you see it worked out through an example. But I like to provide this definition just so you get that practice of reading math vocabulary. We're going to talk about this. So first I'm going to talk about what it is. It's a method of generating, you see this right here, method of generating a list of possible rational roots. So it doesn't just tell you what all the roots are, but it gives you a sort of list of possible roots, possibilities, right? In particular, possible rational roots. Now remember, a rational number is a ratio of integers, right? And an integer, if you don't know what that is, it's like a whole number, which is like counting numbers, right? So like 1, 2, 3, 4, but integers also include negatives. So -1, 0, -2, stuff like that, right? So rational numbers, fractions, right? 2/3 is a rational number. Square root of 2 is called irrational, right? It's a decimal, a non-terminating decimal that does not repeat. You also have complex numbers like I, right? So like 2i or 1 minus 2i, right? So those aren't rational. So the rational root theorem will not find, as it says right here, it will not find irrational or complex roots. But if a polynomial or function, right, has rational roots, then the rational root theorem could be used to find that and then simplify the polynomial, or find a factor of the polynomial that could be further factored to find those roots. And you say, huh? What? You'll see it when I work through the examples. The formal definition, just to talk about it briefly. It says, for a polynomial of the form a sub n x to the n plus a sub n minus 1 plus blah, 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 blah. This is just the general way we write polynomials, where a sub I is an element of z. Okay, so what does that mean? A sub I, this guy, this is just the coefficients, right? So the coefficients are in z, but what is z called? Well, z is called the set of integers. Yeah? Remember that this epsilon means an element of, right? Element of or belongs to. And so you can say the coefficients are in the set of integers. Or another way to just say that is integer coefficients, right? So my coefficients on this polynomial are integers, whole numbers. And the leading term and last term, the last constant and the leading coefficient are not 0. And so any polynomial of this form with integer coefficients basically follows its rational roots are a factor of the last constant divided by the first leading coefficient. So that's kind of what this piece says down here. So right, it says each rational solution, or in other words, rational root, which we could call x, is the quotient of p over q. And this is a simplified fraction, so if you had like 3 over 6, we just write that as 1/2. Then it satisfies two things, where p divides a means p is a factor of a naught. So p goes into a naught, and q goes into the leading coefficient a sub n. Okay, great, Mr. Spake, but what the heck does that mean, right? So here's how you're going to do it. Look at the last term. Look at the last constant. List all possible factors of that, including positive or negative. Then list all factors of the first term, or leading coefficient, including positive or negative. And then just look at their ratio. That will be your list of the possible roots. So here's how this works. 6. 6 is what we call p. Okay? So factors of p, which equals 6, right? 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into itself, right? And notice I put plus or minus on every single one of these. Traditionally when you say, oh, what's the factor of 6, you say just positive 1, 2, 3, or 6, right? But we include minus because we're looking for roots, right? And the roots could be positive or negative, right? They could multiply to get 6 or something like that, okay? And so then I'm going to list the other factors of what's called Q. So this is Q. So P is equal to 6. Q is the leading coefficient on x cubed. That's 1. So I'm going to look at the factors of Q equals 1, which is just plus or minus 1. Now, you're going to take the ratio of this. You're going to divide all of these things, okay? And so what you're doing is you're doing 1 over 1, 2 over 1, 3 over 1, 6 over 1, which, that's a pretty simple list. That's basically what's in the numerator, right? Because if you divide any of those by 1, whatever. Now, what this means is of all these integers here, the rational root is in here somewhere, yeah? One of these, so this, one of those is a root. It has to be. That's what the theorem suggests. So what you can do is test the roots, right? You say, oh, let me use synthetic division because, if they're simple, we're kind of assuming these are all simple roots, right? Because if they're linear like this, if they're a very simple expression like this, then they should be factorable in linear factors, right? And so I could just use synthetic division. You don't have to do long division that take too long, yeah? And so you have 1, 2, 3, 4, 5, 6, 7, 8 different roots to test. Now, you don't have to test all 8 roots. You just have to test roots until you find them, right? So let's just start with 1. I'm using synthetic division with the root 1. Keep in mind my coefficients on this is 1, 0, negative 7, 6. And the reason I have a 0 here is because there's 0x squared, right? So it's 1, 0, negative 7, 6. Got to make sure you have a coefficient on every degree x term, right? Okay. So synthetic division, as we remember, I drop the first number, the 1. I do 1 times 1. Right? I'm doing 1 times 1 is 1. Add these two together, right? 0 plus 1 is 1. 1 times 1 again, so it's 1 times 1 is 1. And then negative 7 plus 1 is negative 6. And negative 6 times 1, this times this, is negative 6. And you add those, you get 0. Oh my gosh, we got lucky. It turns out 1 is, in fact, a root. So do you actually need to keep going? No, you don't. You could just say, look, if you divide this thing, right, if you do x cubed, so if you say x cubed minus 7x plus 6, and you divide that by x minus 1, because you see the root of x minus 1 is 1, so that x minus 1 is a factor of this, then the quotient is x squared plus x minus 6. You can see that's 1x squared plus 1x minus 6, right? You can factor this, right? You can factor this to find the other roots. So I say, oh, look, negative 6 up here, 1 down here. What two numbers multiply to get negative 6 and add to get 1? I'm actually blanking, silly me. 3 and negative 2. And since the leading coefficient is 1, we can just shortcut this and say, hey, look, it's x plus 3 and x minus 2. So the roots are, right? Roots are, I don't like how I wrote that. I'm sorry. Whatever. Negative 3 and 2. I'm wasting time. I already wrote up the notes. I don't need another key. Okay. And so you say, hey, look, I found roots, right? I said, look, I found 3 roots. The first one was 1. then 2, then negative 3. And there I am. I'm done. You can see that, remember, in the last lesson we talked about the fundamental theorem of algebra. And what that says is the degree of your polynomial, which in this case is 3, whatever that degree is, that has the same number of roots as the degree, exactly, right? So since it's a third degree polynomial, I have 1, 2, 3 roots. And that's it. I mean, that's the rational root theorem. You'll notice once you generate this list of possible factors, it's back to the stuff we know, right? We've done synthetic division before. We've used synthetic division to factor and find other roots. I mean, we've done that. All that's new in this lesson is generating this list. That's it. That's all that's new. So I'll do example 2 here. It says, find all roots of this. So this last term, remember, that's going to be p, so that's negative 2. And this first term is going to be q, that's going to be 3. So factors of p include plus or minus 1, excuse me, or plus or 1 and minus 2. And I'm going to look at the ratio of p over q. Oh my gosh. If that's 3, then the factors of 3 are 1 and 3. But now what you're going to do is you're going to look at the ratio of all the ratios of these. So 1 over 1, 2 over 1, 1 over 3, 2 over 1. Or sorry, 1 over 1, 1 over 3, 2 over 1, 2 over 3. That's what I meant to say. Sorry. So you see 1 over 1, well, that's just 1. Then 1 over 3 is 1/3. And then 2 over 1 is just 2. And finally, 2 over 3, that's just 2/3. So again, just like the last one, I have 8 roots to test, and I'm just going to use synthetic division to do so. And it's fine that you have fractions, okay? And I'm going to have a quick word on that when we get there. Now, I'm going to test a couple just to show. I think I remember what they are. So we test 1. I got 3, negative 5, 5, negative 2, right? Drop the 3. 3 times 1 is 3. Then this is negative 2, 3, 3, which gives me 1. So no, 1 is not a root, right? So I test something else. I try negative 1. Negative 1. And I do 3, negative 5, 5, negative 2. Drop the 3. 3 times negative 1, negative 3, negative 8. That's 8. That's 13. That's negative 13. That's negative 15. So no, negative 1 does not work either. Now, because this is a video, I think I remember what the root is. I think it's 2/3, which, yeah, if you go in this list in order, you're going to take a while, right? You're going to do 1 and 1, right? Well, I just did those 2. Then you're going to try 1/3. Then you're going to try 2. And I don't think it works until you get to 2/3. So let's see if I'm right. 2/3. I'm shortcutting this because why would I show you that synthetic division 6 times for the video, right? In class, we split up this work between ourselves, right? In class, we said, hey, you do this one, you do that one, right? Until we found it. So here's 2/3. Drop the 3. 3 times 2/3 is 2. Negative 5 plus 2 is 3. 3 times 2/3 again is 2. That's negative 3. Yeah, sorry. That's negative 2. Okay, so 5 plus 2 is 3. And 3 times 2/3 is 2. And negative 2 plus 2 is 0. Ta-da! Hey, 2/3 actually worked. And that's nice. That's great. So the polynomial that's left over here, right, first of all, 2/3 is a root. So that's special. And this means x minus 2/3 is a factor. Okay? Because that's the root you take. That's what's, right? That's how synthetic division works. Do we usually write it with fractions like this? Not really. We try to keep it whole numbers. But, you know, you'll see as we work this out. Now, this part, which I'll go to blue just because. coefficients here, right, is 3x squared minus 3x plus 3. Now we need to factor this, see if we can find the roots. Factor out the 3, I have 3 times x squared minus 1x plus 1. And so you'll notice something. This guy is not factorable. So I'm going to just say that this is not factorable. Just as a sort of quick note, the full factorization is, well, it's 3 times x squared minus x plus 1, and then this thing, x minus 2/3. So I say x minus 2/3. And I point this out just because we would normally write, right, we would distribute the 3 into this, and you'd write x squared minus x plus 1 times 3x minus 2, right? So if you were questioning, hey, Mr. Spake, why didn't you say 3x minus 2 instead of 2/3? Well, when you test this root of 2/3, this is the factor you're talking about, or that's kind of assumed. The 3 is chilling out here as a result because the 3 was not part of that factor. And then the 3 distributes, and you get this, right? So that's the full factorization, but how do you find the roots? Because that's the goal. You need to find all roots. Use the quadratic formula to find the roots. So, because that's not factorable, right? There's nothing that multiplies to get positive 1 and adds to get negative 1. So I do x equals negative b, which is negative 1, which is positive 1, plus or minus the square root of b squared, which is negative 1 squared, is 1, minus 4ac, all over 2a, like that, right? That's quadratic formula. If you don't know how to use that, hey, go watch another video. That's not this one. 1 minus 4 is negative 3. That's over 2. And we know what the lovely square root of negative 3 is called. It's called 1 plus or minus the square root of 3i. Notice that I is not inside the root. It's the square root of negative, so we call that imaginary, right? And so those are my other two roots. So x, or rather my roots, right, are, well, the first one that I found was 2/3. And then the other two were 1 plus or minus root 3i over 2. I didn't want to write that twice. Plus is one option, minus is the second option. So there are 3 roots, and we are done. Okay? All right. I mean, that's it. That's the video. Yeah, there's nothing more to it than that. That's we're done. Okay? However, in case you're still struggling with this, in case you need to see some more examples, I am going to work some additional examples here just for your pure enjoyment. Okay? So let's just find these. But honest, that's the lesson. If you've got it, go, right? Have fun. You're done. Okay? So let's do some practice problems. Here's, I'm just going to do the same process I do, which is generating that list. So P is going to be 8 and Q is going to be 1. Now, because I'm dividing by 1, right, P over Q, well, factors of 8 are 1, 2, 4, and 8. And this is all over plus or minus 1, so I really just need that list, right? And so let's just get to testing. Right, I mean, if you want me to write it here, I can. That's the list, but I mean, you're just dividing it by 1. So let's test number 1. Let's say 1, negative 5, 2, and 8. These answers I don't remember, so we're just going to kind of do them. Okay, so 1 didn't work. Let's try negative 1. I'm not going to explain synthetic division every time, right? 1 times negative 1 is negative 1. I'm just kind of doing this. You're following along. Oh, thank God. We got lucky. Negative 1 was a root. Yay. Okay. I was kind of like, oh, how many of these are we going to do? Negative 1 worked with synthetic division, right? So I have x squared minus 6x plus 8. And so we're going to factor. Here's 8. Here's negative 6. What two numbers work? Negative 4, negative 2, which means this factors is x minus 4, x minus 2. So the roots are x equals 4, x equals 2. So I think I'm done, right? My roots, I found 1 at negative 1 through the rational root theorem and testing with synthetic division. And then I found the other 2 at 2 and 4. And that's it. There's my roots. Ta-da. Okay. Let's look at number 2. So I'm going to list all the possible rational roots here. Now, before I do that, before you give yourself a headache on listing 12, because that's 1, 2, 3, 4, 6, 12, always look for GCF first. Factor out GCF. X cubed minus 6x squared plus 11x minus 6. Notice I factored a 2 out because they all were divisible by 2. So P is 6, Q is 1. I mean, it's negative 6 technically, but who cares? So factors of P, factors of 6, well, that's just going to be 1, 2, 3, and 6. Factors of Q, which is just 1, is just plus or minus 1. And so you're going to save yourself a lot of work because if you did 12 and 2, you'd have a lot more factors to test. And so we're just limited to this list here. Again, I don't remember which one works, but I'm tired of testing 1. I'm going to try, let's try the other end. Let's try 6. Here's 6. 2, negative 12, 22, negative 12. I don't know if I want to do 6, actually. 2 drop the 2. 2 times 6 is 12. Okay, actually, I think I like that. 0. 0 times 6 is 0. 22. And 22 times 6, nah, it's not going to work. Don't care. You know it's not going to work, right? 22 times 6, whatever the heck that is, that's not going to make a remainder of 0. So, no. No, thank you. Pass. Let's try negative 6. And I'm going to list all the coefficients here. So drop the 2. I do have the right coefficients. Okay, good. Oh, wait. Oh. Uh-oh. Hold on. Mr. Spake has made a blunder. Back up, back up, back up. Beep, beep, beep. Okay, sorry. You factored 2 out. Look, and the reason it still works. Okay, it's fine. I can still use it with this. It's fine. It's fine. It's fine. It's just that I'm making it harder on myself with that 22 and all that stuff. Let me use these coefficients instead. Okay? It's technically not wrong. Okay? I didn't do anything wrong. But yeah, I will it'll be easier if I use these simplified coefficients by dividing by 2. So 1 times 6 is 6. I already know this doesn't work, but whatever. I can more clearly see that doesn't work, right? Saves me a little bit of math there. Let's try negative 6. We'll do 1, drop the 1. So negative 6, 11, negative 6. So 1 times 6 is negative 12. I say, nah. You know that's not going to work. Negative 12 times 6, you can put that with 11? Yeah, right. Give me a break. Let's try 3. 1, negative 6, 11, negative 6. Drop the 1. 1 times 3. Negative 6 plus 3 is negative 3. That's negative 9. Ooh, 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 ooh. 2 times 3 is 6. There we go. There's the cash money, baby. We did it. We did it. X squared minus 3x plus 2. You found it. Or I found it. What did you do? Just kidding. X squared minus 3x plus 2. Let's factor that. Here's 2. Here's negative 3. Negative 2, negative 1 work. So this factors is x minus 2, x minus 1. So the roots are 2 and 1. And wow, I say LOL. If I had tested 1 like I've been doing, it would have worked, huh? Oh well. You live and you learn. The roots are 1, 2, 3. Yeah. 3 worked, and then the other 2 right there. Okay. I guess I should have just tested 1, but whatever. All right, on to example 3. These are maybe a little bit more difficult just because of the techniques after. So I can see that P, the last term, is 4. The first leading coefficient is 1. So I know that, look, it's going to be 4 over 1, whatever. It's going to be plus or minus 1, plus or minus 2, plus or minus 4. Those are going to be the possible rational roots, because you take all the factors of 4 divided by all the factors of 1, and there you go. So let's not make the same mistake Mr. Spank made. Let's test 1 to start off with. And the coefficients are 1, -7, 16, -14, and 4. We'll use synthetic division. Drop the 1. 1 times 1 is 1. Add that's -6. And add this here, that's 10. 10 times 1 is 10. That's -4. Oh my gosh. Listen to your gut, huh? So this is, remember, that's the remainder. So that's x to the 0, that's x to the 1, x squared, x cubed. So it means I got x cubed minus 6x squared plus 10x minus 4. Now, what do I do with that? Well, I could try grouping x squared, x minus 6, plus 2, 5x minus 2. Uh-oh, that doesn't work, right? Grouping doesn't work. So I can't continue to factor by grouping. I have to do that. I have to use the rational root theorem again, more. I have to do it more, right? So take the coefficients of that new quotient polynomial and keep testing roots, right? You could use the original, but if you just remember how we said if q of x divides p of x, we've said this in the earlier lessons, then the roots of q of x equals 0 are roots of p of x equals 0. So every time you divide this by something, this is like a polynomial is like a q of x. So if you find the roots of this guy, that's a root of this guy. So I'm just going to use synthetic division on the simplified thing. So I'm going to just jump to 2. Let's see if 2 works. 1 times 2 is 2, -4, -8. No way that worked. No way. Did it really? Did I actually get that lucky? I just did 1 and 2. I dropped the 1, 2, 22. Just double checking my math here. Yeah, it looks good. So I'm left with x squared minus 4x plus 2. Okay, let's see if that's factorable. So that's 2, that's -4. Nope, because the only thing that works would be 2 and 1 to get that 2. And that ain't working. So, not factorable. So you say, hey, how do I solve when it's not factorable? Right? What do I do? What shall I do? Well, it's what we did in the last example. It's quadratic formula. So x equals -b, which is -4, which is +4, plus or minus the square root of b squared, which is -4 squared, which is 16, minus 4a, which is 1, times c, which is 2, all over 2 times 1, because a is 1. Yeah, that's just my variation where I actually explain what I'm plugging in instead of just singing the song. So x is 4 plus or minus, what is that, 16 minus 8, which is 8. Oh my gosh. Over 2. And simplify square root of 8. You should find that it's 2 root 2. Hey, if you need a second to figure that out, you can. Pause the video, figure out why root of 8 is 2 root 2. 4 over 2 is 2, and 2 over 2 is 1, so it's 2 plus or minus root 2. So, what are my roots? I should have 4. And the reason I have 4 is the degree is 4, right? Degree of this polynomial is 4. So I found through synthetic division 1 and 2 worked, and then using the quadratic formula because it wasn't factorable, 2 plus root 2 and 2 minus square root of 2. And so those are all the roots. Yay! Okay. I've already made my key, so I don't need this. Hopefully you got that down. You can reverse the video if you need to see them again. All right, last one. Again, I'm just working example problems, right? If you're saying, what the heck is synthetic division? You have missed a video, my friend. Go back to 5.2 and watch synthetic division, okay? GCF? No GCF. Okay, fine. The last term is 6, so we're going to do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 over the first term, which is plus or minus 1, plus or minus 3. Now, you got to do, this is where it gets annoying, you have to do all the variations of this, right? So 1 over 1 is 1. 1 over 3 is 1/3. And so what I'm doing is that one and that one. Then I'm going to do 2 and 3, and then 3 and 1, 3 and 1 and 3 and 3, and then 6 and 1 and 6 and 3, right? So that's what I'm doing. 2 and 1, that's 2 over 1 is 2, then 2/3, then 3, then 3/3, but 3/3 is 1, and then 6, and then 6 over 3, but that's 2. Yikes, that's a lot. Oh boy, oh boy, oh boy. I wonder where these roots are. Well, let's test, I guess. And the one I give on the test isn't as bad as this, I think, but it's still a lot, but whatever. Drop to 3. 3 times 1 is 3. That's 20. There's no way. There's no way this works. Actually, hold on. 20 times 1 is 17. Okay, 34. Okay, yeah, nah. Let's try negative 1. 3, 17, 3, 17, negative 6. So drop the 3. 3 times negative 1. That's 14. 14 is a negative 14. That's negative 17. Ooh, tingling. But that's positive. That's 34. Nope. L. Say L. That did not work either. So, nope. Okay. Sure, let's embrace the fractions. Let's just do it. 1/3. Let's try 3, 17, negative 3, 17, and negative 6. Let's drop that 3. Let's see if this works. 3 times 1/3 is 1. That's 18. 1/3 of that is 6. Those two together are 3. That makes another 1, another 18, and then a 6. Hey, howdy. 1/3 actually worked. Thank goodness. Cool. So that means I'm left with 3x cubed plus 18x squared plus 3x plus 18. Those could all be divided by 3, so let's go ahead and do that. Put out a 3, and then I got x cubed plus 6x squared plus x plus 6. And I say, oh, can I do factor by grouping here, right? Let's see. Let's take out an x squared. I get x plus 6. GCF of x plus 6 is just 1, so that's x plus 6 as well. So yeah, factor by grouping did work. I don't need to do more synthetic division. I get 3x squared plus, what am I doing? So the way this factors is 3 times x squared plus 1 and x plus 6. Now, what are the roots? X plus 6, the root of that is negative 6. But how do I find the root of x squared plus 1, right? Well, it's x squared plus 1 equals 0. Subtract 1 from both sides, you get x squared equals negative 1. Take the square root of both sides, you get plus or minus the square root of negative 1. But we call that I. And there it is. I found all the other roots, right? I tested 1/3, and then from that, I fully factored this by using grouping techniques in GCF. And then I found one of the roots to be negative 6, and the other root to be positive or negative I. So my roots are 1/3, negative 6, I, and negative I. And I am done. I say, I am done. There's a little happy face. Okay, and that's the video. Yeah. I hope those examples worked out, kind of give you an idea. Maybe not. I mean, again, all that's really new in this video is generating this list, right? All of this stuff we've done before, but just in case you were stuck on these problems, needed some help, I hope this video was of some assistance. And I want to remind you, I'm not sure if I said this early in the video, but I just want to remind you, if you're still here at the end with me, this is a last-ditch effort for factoring. Always try every other factoring technique prior to doing this. So grouping, sum and difference of cubes identity, factoring like a quadrant, I mean anything, GCF, right? Always try that first. But if nothing works, try this, okay? This is your last-ditch effort that can help find possible roots, rational roots. Okay, so that's the video. Hope you enjoyed. Have a lovely evening or morning or afternoon or whenever you're watching this, and I'll see you later.